Okay, welcome to the Basic Computer Repair and Networking, Chapter 1, Introduction to a Typical PC presentation lecture. Please make sure that you have the note guide that accompanies the Chapter 1 presentation lecture so that you can get notes down on the Chapter 1 material as we move through the content for Chapter 1. Let's take a look first at what a computer is. A computer is an assembly of electronic modules that interact with computer programs known as software to create, modify, transmit, store, and display data. A lot of us know how to use a computer, but have we ever actually defined what a computer is? Well, there is an example of a definition. Computers have rapidly evolved over the last number of years, and they also appear to be intelligent, but really all they do is process and store data. Data is information that is stored and processed by all computers. Data inside the computer is represented electronically. Data in a computer system is represented as ones and zeros. This is also known as the binary system. This is how computers can communicate and interpret data in order to store it and process it. Computer data codes. Now, these binary numbers can be represented by ones and zeros and can translate into numbers, text, pictures, or even sound. Data can be expressed in different forms. We could be talking about voltage levels, numeric systems, which is the binary and hexadecimal system, which we will actually practice using, as well as symbolic codes, as the ASCII code, ASCII. Data should be expressed in a way that is easiest to grasp for the given material. Okay, so we're going to practice using some of these different codes in order to present text, pictures, or even sound. We're going to stay away from sound and just do text, pictures, and symbols. Now, the binary number system, this is entirely ones and zeros. So the combination of ones and zeros and where they are is going to tell the computer exactly what data to either retrieve, process, or store. Digital devices have two states, off and on, which are reflected in the two numbers, 0 and 1. So one of them is off, the other one is on. Ones and zeros of this system are used to represent the high and low voltage signals. Thus, basically a computer language, how computers communicate. The binary system would be looking like this. So if we have 4 zeros, that's going to equal the 0 number. The far right-hand digit, being a 1, is going to be the number 1. The third digit, being a 1, is going to represent the number 2, and so on. Now, how is it determined which numbers represent which binary combination? Well, let's take a look at that. The hexadecimal system is a computer code system that uses 16 characters. Now, the system is going to use a combination of of numerals 0 through 9 and letters A through F. That's what's going to be represented by this hexadecimal number code. It best matches hardware systems of the computers, and also the system can be used in combination with the binary system. All right, so the binary system, hexadecimal system working together, similar computer languages reflecting different deliverables. So let's take a look at the hexadecimal system. So in the hexadecimal system, a hexadecimal 0 is going to be also the decimal number 0. Hexadecimal 1, decimal 1, all the way through. But then once you get past the number 9, now you move into numeric characters. The capital letter A is going to be 10 decimal. The capital letter B is going to be 11 decimal, and so on. All right. This all might be difficult to comprehend at this point, but once we actually put it into practice and put it into play, it should make more sense. Now, the American Standard Code for Information Interchange, which is also known as ASCII, ASCII, is the symbolic code in which data can be expressed. Now, it was the first attempt to standardize computer character codes amongst the varieties of different hardware and software, thus putting some type of a commonality in terms of language as to how different computers are going to communicate. Now, it also had limitations such as not allowing for variations in fonts, common requirement for word processing software. So, not only was this an attempt to simplify things, but it also did present some challenges. Bits, bytes, and words. Now, when it comes to different amounts of data, different amounts of data are allocated in these different terms. So bit, byte, and word are basic computer units of data, which is based on the binary number system. A bit, short for binary digit, is a single binary unit of 1 or 0. A byte is 8 bits, and a word is the total amount of bytes a computer can process at one time. All right? So again, probably a little bit more confusion as to how computers communicate and also process data, but once we get to practicing it, you're going to see how it all fits together. Let's take a look at this little table here. So if we take the unit of bit, byte, or word, the definition of a bit is going to be a 0 or a 1. An example of a bit is 1. Now a byte is going to be 8 bits, which is a combination of 8-bit digits. So an example might be 0, 1, 0, 1, 1, 1, 1, 0. A word is 1 to 8 bytes. An example of all of those binary digits combined to make a word. So again, the confusion might still be there, but we're going to get a chance to practice this. We will be practicing it in class with a number of different guided practice and independent practice activities. Let's take a tour outside of the computer case. A minimal workstation consists of a number of input and output devices. These you're probably going to be most familiar with. Now, the computer is the case that houses motherboard, CPU, memory, as well as hard drive. Typical input devices are going to include things like the keyboard or the mouse. And typical output devices are going to be displaying data and information to the user, such as the monitor, printer, as well as speakers. Peripherals. These are optional pieces of equipment that aren't necessarily needed in order for the computer to operate. So, monitor is going to display data as words or pictures. A printer is going to print data in printed form. Speakers convert data to sound. Keyboard is used for the user to enter data into the machine, and a mouse is also used to interact with coordinates on the display, and a touch screen can be both input and output. Now, there are many different styles used to contain or protect the electronic part of the computer. Most common case styles, and we're going to take a look at all of these, is a desktop, a tower, mini tower, micro tower, laptop, and notebook. We will actually get an opportunity in class to take a tour of the inside of a computer case to see how all those parts are in that particular case and what their purpose is. So, the exterior of the computer allows access to the electronic parts inside. Data can be entered through the hard drive, optical drive, keyboard, mouse, or one of the ports on the back. We will talk about those ports as well, as they are connected to the motherboard for data processing. Here is an example of a computer case. Let's take a look at the exterior case connections. We have a PS2, which is the green mouse, or the PS2 purple, which is the keyboard. Not as common anymore. A lot of them are USB. There's a coaxial audio out. There's the parallel port, which was used for older printers. There's the RG5 or LAN for hardwired network connection. And there's a secondary port as well. There's also a line in for sound purposes, line out like for headphones, or even if you want to attach a microphone. There's the side speaker, center speaker, if there's a number of speakers that are attached to this particular PC, rear speaker, USB port, an IEEE 1394, also a Tosk-Link audio out. All of these are different aspects of how the computer can process sound and or other data. Now, the inside of the PC has several standard components, the CPU, power supply, all of these in which you will get a chance to research in class with guided practice as well as independent practice activities. The CPU, or central processing unit, is also known as the brain of the computer. Examples might be a Pentium, Intel, Celeron, or even AMD processor. All of the components of the computer are going to depend on the CPU. The CPU is going to control data within the computer, translate commands into actions, and even carry out program codes written in software programs. Examples of what a CPU might look like. Here is an AMD 64. This is what you will see inside the computer case so that you know and can locate the CPU. The power supply is going to convert 120 volt AC power in order for the computer to be powered up. The hard drive is where all of the computers and data is stored, also known as a hard disk drive. These can be internal or external, and they also operate as magnetic patterns of the hard drive in order to store that data. Here's an example of what a hard drive and a power supply might look like. So keep these in mind when we go through our tour of the case. Motherboard is usually the rectangular piece. It's the circuit board covered by many conductors. It allows different components of the computer to be plugged into it for processing. It provides a way to distribute digital signals as well as an electrical system pathways referred to as computer bus. Here's an example of the motherboard, what this might look like. And they all are different with different ports and components. Random access memory, or RAM, is where computer programs are loaded to in the hard drive. The RAM is classified as a volatile memory, meaning that data is lost when the power is turned off. RAM is required to run applications, and RAM amounts might vary. RAM is where data is temporarily stored and emptied when the computer is turned off. RAM chips look like this, and they can have different standard amounts, 256 gig up to a couple terabytes, I believe, is as far as they've gone now. Battery supplies voltage to the CMOS, which contains the firmware and setup data. This is in the motherboard. In the event that power is lost to the PC, that battery then can at least keep some things up to date and is going to allow information to be saved while the PC is on. Without that, the computer would lose track of its date and time, and that's an issue that if you know that your computer is not reflecting the accurate time and or date, it could be an issue with that battery. Here's an example of what that battery might look like, the computer battery. Not to be confused with, like, say, a laptop battery, which would power the entire unit. Expansion card. The expansion card now is a board that can be easily installed in a computer to enhance or expand its capabilities. Expansion cards are also known as interface card or host adapters. They could be devices such as TV tuners, video cards, sound cards, and even modems. Many devices designed to be added expansion cards have been redesigned as exterior devices that connect typically through a USB port. Here's an example of an expansion card, which would be connected into the motherboard. Now, the expansion card slot is a receptacle for an expansion card. Cooling fans are necessary because they are a constant stream of air that keeps the computer cool so it doesn't overheat. Cables such as SATA and PATA connect the motherboard to devices such as hard drives and other optical drives. Now, the expansion card slots, see the arrows here, PCI slots are all throughout the motherboard and can house many different expansion slots and different data cables, PATA and SATA. SATA being the more common nowadays. Data is serial versus parallel data transfer. Serial data is sent through a port 1 bit at a time in successive order, where parallel transfer, more than 1 bit is sent side by side 8 bits at a time. Obviously, in this case, the parallel transfer is going to be the faster way of transferring data. Here is an example or a picture of serial and parallel data transfer and how it works. So we can see how the data is going to move, either bits and or bytes. Parallel data is going to allow for more data to be transferred at one time, thus obviously increasing the speed. And that concludes the presentation lecture for the typical PC. Please make sure that you review any of the slides if need be in order to complete the note guide, and I will see you next time we meet in class.